So now that we understand, I hope, what the discriminant is, we're going to go ahead and calculate it for these two problems. Identifying A, B, and C is as easy as going 2, 6, 3. 2, 6, 3. If any of the terms weren't there, what would B be in that case? 0. What would C be in this case? 0. All right? If it's not there, it's a 0. What if this 2 wasn't there? What's A? 1. Correct. So now we're going to change to blue and just calculate the discriminant portion of the quadratic formula. I do this for two reasons. One, that's kind of the more complicated part of the quadratic formula, so let's just get it out of the way first. And second, it gives me an idea of what my solutions will look like. It's like testing the water before you jump in the pool. All right? It's going to tell us, I think I'm only going to get one answer. Maybe I'll get two answers, or maybe I'll get two imaginary answers, like in B. All right? But in this one, 6 squared minus 4ac came out to be what? 12. The discriminant is 12 in this problem. That simply tells me that I expect to have how many solutions? 2 real solutions. So this parabola will actually hit the x-axis somewhere if you were to graph it. All right? Here we go. In the other one, part B, did you find the discriminant? Did you get negative 80 or negative 88? Did anyone say negative 88? A few people throughout the day have gotten negative 88, and others are getting negative 80. All right? And if you note the use of my parentheses here, make sure you definitely use them here when we do A, B, C. Negative b squared minus 4ac, it is going to be negative 80. Because the calculator, if you forget to use your parentheses, will not calculate that correctly. Here we go. Parentheses b squared minus 4ac. Negative 80, okay? So the discriminant is negative 80 for that problem. Therefore, A will have 2 real solutions. B will have 2. I called them imaginary, but technically they're called 2 complex solutions. Let's continue. Here we go. Let's actually find the solutions. And for that, we go back to the quadratic formula. We need negative b over 2a plus and minus the square root of, what did we pre-calculate? What's that part called? The discriminant, 12 over 2a. For the next one, same idea. X equals negative b over 2a plus and minus the square root of negative 80. We're using that part that we set aside for later. Fill in the a's and the b's, and you'll get 2 solutions. They will be decimals. The one on the left will be real numbers. The one on the right is going to involve I. Here we go. X equals the opposite of b over 2a plus minus the square root of 12 over 2a. Let's finish this one. This should be negative 6/4 plus minus. I think you guys are kind of growing up now. You should be used to 12 is 4 times 3. I can bring out a 2 root 3. Do you understand that? That's called simplifying a radical, all right? And finally, negative 3 over 2 plus or minus root 3 over 2. Because this 2/4 reduces to 1/2. Those would be your two solutions, and we'll check them in the next video. All right. And the other one. Sorry, I'm racing a little bit, just trying to get these done. Here we go. ABC. We need the opposite of B over 2A plus minus the square root of negative 80 over 2A. We pre-calculated the discriminant. We're definitely going to get I, and here's where it happens. We have to square root negative 80. Quick check here. This was supposed to be the opposite of negative 2. Therefore, we're going to get 2/6 plus or minus. I'm going to show this simplification. Don't know how I got the 4i root 5? Negative 80 breaks up into negative 16 times 5. What do we call the square root of negative 16? 4i. The square root of 5 is stuck under the radical. Finally, we get 1/3 plus minus 2i root 5 over 3. That was just simplifying 2/6 to 1/3 and 4/6 to 2/3. Those are the answers. There's no way we would have gotten those answers by factoring 10 minutes ago. Agree? Agree.